Hi, myself Nitin MS. I am from Sri Venkateswara College of Engineering. Currently, I am studying in 6th semester Department of Computer Science and Engineering. In this video, I am going to present the topic about solar photovoltaic system with its applications. Now let us discuss about the introduction of photovoltaic systems. Improvements in quality of life and rapid industrialization in many countries are increasing energy demand significantly, and the potential future gap between energy supply and demand is predicted to be large. Interest in sustainable development and growth has also grown in recent years, motivating the development of environmental begin energy technologies. Research on applications of solar energy technologies have as a consequence expanded rapidly, exploiting the abundant, free and environmentally characteristics of solar energy. However, widespread acceptance of solar energy technologies depends on its competitiveness, considering factors such as efficiency, cost effectiveness, reliability and availability. Renewable energy sources can be defined as energy obtained from the continuous or repetitive currents on energy recurring in the natural environment, or as energy flow which is replenished at the same rate as they are used. All the Earth's renewable energy sources are generated from solar radiation, which can be converted directly or indirectly to the energy using various technologies. This radiation is perceived as white light since it spans over a wide spectrum of wavelength, from the short-wave infrared to the ultraviolet. Such radiation plays a major role in generating electricity, either producing high temperature heat to power an engine, mechanical energy, which in turn drives an electrical generator, or by directly converting it to electricity by means of the photovoltaic. Photovoltaics is a method of converting solar energy into direct current electricity using semiconductor materials that exhibit the photovoltaic effect. A photovoltaic system employs solar panels composed of a number of solar cells to supply usable solar power. Power generation from solar photovoltaics have long been seen as a clean, sustainable energy technology which draws upon the planet's mostly plentiful and widely distributed renewable energy sources. This is the image of photovoltaic systems, which show how the solar energy is captured by the solar panels and it converts the energy for many other devices for their working purpose. As we can see here, the solar energy is being captured by the solar panels, and then the flow of the energy is being transferred to many other devices so that all the devices can work according to their purpose. These are the few components that have been used in the previous image. There are solar arrays, mounting systems, cabling, solar trackers, solar inverters, charge controllers, battery. PV technology classification. There are two types of PV technologies: thin film technology and silicon film technology. Silicon film technology is further classified into two types: monocrystalline and polycrystalline. Let us discuss about the thin film technology first. Thin film technology. Silicon deposited in a continuous on a base material such as glass, metal or polymers. The efficiency ranges from 5% to 13%. Thin film crystalline solar cell consists of layers about 10 micrometer thick compared to 200 to 300 micrometer layers for crystalline silicon cells. Pros, that means the advantages of thin film technology. They are low cost substrain and fabrication process. Cons, that means the disadvantages of thin film technology. Not very stable. Now let us discuss about the silicon crystalline technology. Currently makes up 86% of PV market. Very stable with module efficiencies, that is 10% to 16%. The two types of silicon crystalline technology are monocrystalline PV cells and polycrystalline PV cells. Monocrystalline PV cells. Monocrystalline silicon cells. Conversion efficiency for this type of cells ranges from 13% to 17% and can generally be said to be in wide commercial use. In good light conditions, it can be most efficient photovoltaic cell. Polycrystalline photovoltaic cells. The production of these cells is economically more efficient compared to monocrystallines. The efficiency ranges from 10% to 14%. Construction of solar cells. This is a simple construction of solar cell. Let's see the working of solar cell. Photovoltaic cells are made up of at least two semiconductor layers. One layer contains a positive charge, the other a negative charge. Sunlight consists of little particles of solar energy called photons. As a PV cell is exposed to this sunlight, many of the photons are reflected, pass right through, or absorbed by the solar cell. When enough photons are absorbed by the negative layer of the photovoltaic cell, electrons are freed from the negative semiconductor materials. Due to the manufacturing process of the positive layer, these freed electrons naturally migrate to the positive layer, creating a voltage difference similar to a household battery. When the two layers are connected to an external load, the electrons flow through the circuit, creating electricity. Each individual solar energy cell produces only 1 to 2 watts. To increase power output, cells are combined in a weather-tight package called a solar module. These modules are then wired up in serial and or parallel with one another into what's called a solar array to create the designed voltage and output required by the given project. Now let us discuss about the applications of photovoltaics. Commercial lighting. PV powered lighting systems are reliable and low cost alternative. Security, billboard signs, area and outdoor lightings are all viable applications of PV. Consumer electronics. Solar powered watches, calculators and cameras are all everyday applications of PV technologies. Telecommunications and residential power. A residence located more than a mile from the electric grid can install a PV system more inexpensively than extended the electric grid. Over 5 lakh homes worldwide use PV power as their only source of electricity. So let's end the video here and thank you for listening to my explanation and visiting my channel.